Hi there, and welcome to Ku English. In this series, we explore the lives of amazing people and help you improve your English at the same time. Ready? Let's dive in. Warren McCulloch, Struggle, Turning Points, and Recognition, Part 3. Chapter 1, Years of Being Ahead. By the mid-1950s, Warren McCulloch had already influenced a generation of thinkers. Yet, the broader scientific world did not fully recognize what he had helped to begin. His 1943 paper with water pits had planted a seed, but seeds do not always grow immediately. Sometimes they remain beneath the surface, waiting for the climate to change. Artificial neural networks, as an idea, moved in and out of fashion. Early enthusiasm was followed by skepticism. Machines were limited, computing power was scarce, and simplified neuron models could not yet perform impressive tasks. Critics argued that the brain was far too complex to be reduced to logical circuits. Others dismissed cybernetics as speculative. McCulloch did not retreat, but he felt the resistance. He was a theorist in a scientific culture that increasingly valued narrow specialization and measurable results. Funding agencies preferred projects with predictable outcomes. His ideas were bold, but difficult to test directly. At the Research Laboratory of Electronics at MIT, where he later worked, he found himself surrounded by brilliant engineers and mathematicians. The atmosphere was energetic, competitive, forward-looking. Yet even here, tensions existed. Some researchers pursued increasingly technical paths in computing, leaving behind the philosophical depth that had once animated cybernetics. McCulloch sensed a shift. The interdisciplinary dream of the Macy conferences was fading. Fields were separating again into distinct territories. The language of systems and feedback remained, but the broad, almost poetic ambition of early cybernetics was narrowing. In conversations, he could be both inspiring and frustrating. He moved quickly between concepts, drawing connections that others did not always follow. His mind operated associatively. He trusted intuition shaped by decades of reflection. Younger scientists sometimes preferred clearer formulas and practical algorithms. There were moments when he wondered whether he had become a figure of the past, respected, cited, but no longer central. Neural network research entered what later historians would call a winter. Optimism cooled. The limitations of early models were exposed. Yet even during these colder years, McCulloch continued thinking. He returned repeatedly to fundamental questions. What makes a system self-organizing? How does a network achieve stability? How can circular processes generate meaning? He explored the mathematics of recursive functions, fascinated by systems that referred to themselves. The image of the brain as a dynamic network never left him. He knew that early models were crude. He did not mistake them for the full truth, but he believed they pointed in the right direction. He had lived long enough to understand that ideas move slowly through culture. Being early can feel like being wrong, but sometimes it simply means that time has not yet caught up. In quiet offices and lecture halls, he continued speaking of neurons as logical units, not because the model was complete, but because it was fertile. It invited exploration. The breakthrough he sought was not applause, it was coherence. And coherence, he believed, would eventually emerge. Chapter 2, Recognition Without Rest. In the 1960s, the intellectual world began to change again. Computers grew more powerful. The language of information processing spread beyond engineering into psychology and linguistics. Scholars spoke of the mind as a system that encodes, stores, and transforms information. In this shifting landscape, McCulloch's earlier work gained renewed attention. Researchers revisited the logical neuron model as part of the emerging cognitive sciences, though more sophisticated approaches developed. The conceptual step he and Pitts had taken, treating neural activity as computation, remained foundational. He received invitations to speak, to advise, to reflect. Younger scholars approached him with respect. Some called him a pioneer. He listened with a mixture of satisfaction and detachment. Recognition did not bring him peace. If anything, it intensified his awareness of unfinished questions. He understood that modeling logic in neurons did not explain subjective experience. The hard problem of consciousness, though not yet named as such, lingered beneath discussions of circuits and computation. He often spoke of the brain as a network of constraints, a structure that limits possibilities in order to generate meaningful patterns. To him, intelligence was not magic, but organization. Yet organization alone did not capture the richness of human life. His lectures retained their distinctive style. He quoted Aristotle, invoked theological metaphors, and then shifted suddenly to equations. Audiences sometimes struggled, but they sensed depth. He did not offer simplified narratives. He demanded intellectual engagement. Privately, he carried a more somber awareness. Walter Pitts, his brilliant collaborator, had withdrawn almost completely from public life. Pitts struggled with mental health and alcoholism, eventually dying in relative obscurity. McCulloch felt the loss deeply. Their partnership had been one of rare intellectual symmetry. The success of an idea does not erase the fragility of those who create it. In professional circles, debates continued. Symbolic approaches to artificial intelligence competed with neural models. Some researchers argued that high-level reasoning required symbolic manipulation rather than distributed networks. Neural networks were criticized for their limitations. McCulloch watched these debates with interest. He did not see them as contradictions. To him, symbolic systems and neural networks were not enemies, but layers of description, different languages for different aspects of mind. Yet, the scientific community often prefers clear victories and defeats. Fields rise and fall with fashion. He had learned not to tie his identity to popularity. There was a quiet dignity in his later years. He no longer needed to prove himself. His ideas had entered the bloodstream of modern thought. Even when not cited directly, they influenced the vocabulary of computation and cognition. He once suggested that, to understand the brain, one must be willing to think across boundaries between biology and logic, between mathematics and poetry. This refusal to narrow his vision sometimes cost him clarity in the eyes of others, but it preserved something essential. Recognition came, but it came slowly and unevenly, and beneath recognition remained the deeper question: what had his life truly built? Chapter 3. The Weight of a Lifetime of Thought. As Warren McCulloch entered the final years of his life, he carried not only professional achievements, but decades of intellectual tension. The boy shaped by Protestant discipline, the student of philosophy, the medical researcher, the founder of neurologic, they all lived within him. He reflected often, not in public confessions, but in conversations and writings. He considered how far science had traveled since his youth. Machines now performed calculations once unimaginable. The language of computation had reshaped psychology and neuroscience. Yet he remained cautious about triumphalism. He knew that models are tools, not mirrors. He resisted simplistic claims that the brain was just a computer. The analogy was powerful, but incomplete. Living systems were embodied, adaptive, and embedded in culture. Computation described structure, but life involved context. In some ways, he remained a philosopher to the end. He did not regret his efforts to formalize neural activity. On the contrary, he saw it as necessary. Without abstraction, science cannot move forward. But abstraction must remain aware of its limits. There were moments of quiet satisfaction. Former students continued the work. New generations explored neural networks with increasing sophistication. Though the field would experience setbacks, it would also return stronger, deeper, more computationally capable. McCulloch did not live to see the explosion of deep learning decades later. He died in 1969 at the age of 70. But the intellectual lineage was clear. Artificial neural networks, cognitive science, computational neuroscience, all bore traces of his early vision. Still, legacy is complicated. Some remembered him as a visionary. Others saw him as too abstract, too speculative. His interdisciplinary style, once radical, later became fashionable under new names. Cybernetics fragmented, but its spirit survived in systems theory and information science. In the final balance, his life was not a straight line of success. It was a series of crossings between faith and doubt, logic and biology, isolation and collaboration. He stood repeatedly at borders. The breakthrough was not a single discovery. It was a shift in language. He helped humanity imagine the brain as something that could compute, that could be modeled, that could be understood structurally. As part 3 closes, we see a man who experienced both resistance and recognition, both partnership and loss. He did not solve the mystery of mind. No one has. But he changed how the mystery could be approached. In part 4, we will consider what remains after a life like this, what endured, what was misunderstood, and what price was paid for thinking across worlds. Thanks for learning with Ku English. Don't forget to like, share, and subscribe. Until next time.